Air circuit breakers, or ACBs, are used widely on the low voltage system. They are used on higher current, lower voltage industrial circuits. They are the most advanced low voltage protection device that we use, and they normally have multiple time and current curves available. They tend to be used where we need incomer circuit breakers, as they have more features and settings than miniature circuit breakers and fuses. Air circuit breakers tend to be used on incomers due to the high rating required and the wide range of time current characteristics available, which allow it to successfully discriminate with all of the equipments farther down the system. They are normally supplied with software packages, which permits all of the curves to be selected and set from a PC via a standard USB port. This makes life a lot easier, as setting ACBs can be quite complex when you have to do full discrimination with other devices. Here we have a 120 amp rated air circuit breaker protecting a feeder. The difference between the air circuit breaker and the fuses and MCBs that we've looked at so far is that this device is fully programmable and has a variety of curves and characteristics available. A typical curve we normally use is the standard inverse curve. This is two parts. The first part has the standard time current characteristics that we see on a fuse, and it follows the normal philosophy that if the current increases, the operating time reduces. The second part to the curve is a definite time element, so that if the current goes above a certain level, the circuit breaker will trip in a defined time. The curve defines a no-trip zone and a trip zone. Let's now close the circuit breaker. The current now increases. The value of the current will depend on the load. If the current magnitude keeps it within the no-trip zone, the air circuit breaker will not react. If the current increases and goes above this level, we get onto the standard inverse characteristic. The operating time of the device now depends on the magnitude of the current. After the defined time delay, the circuit breaker trips, removing the load from the system. The difference with the air circuit breaker compared to the MCBs and fuses is that we can change the settings of the standard inverse curve. This has the effect of moving the curve around the graph, which allows us to provide excellent discrimination with the MCBs and fuses that have a fixed setting. This is why we normally use air circuit breakers on incomers. In addition to the standard inverse curve, we have numerous others, including the very inverse curve, the extremely inverse curve, and the definite time characteristic, which obviously gives a defined operating time once the current reaches a certain magnitude. Again, all of these curves can have their settings altered to provide good discrimination with other devices. Let's now see how the definite time characteristic operates. The current now increases as the load increases, but the ACB will not react until the current exceeds the defined setting. Once it does, the circuit breaker reacts in the set time, removing the load from the system. The definite time curve is a very useful feature and is normally set to a level that protects the integrity of the cable and bus bars connected to the feeder.